will quantum computing affect blockchain? This video was created through the combined effort of the QRL contributors community. Let's start with some blockchain basics. When you first buy cryptocurrency, you should store your coins or tokens in your own personal wallet. This is the safest, most secure way to store your funds and avoid being a victim of exchange hacks or dodgy software. When you create your first wallet, you are creating a cryptographic address consisting of a public key and a private key. You will be the only one that knows your private key, and the public key is what is known as a public address, which you will share. You can send coins from your public address to other public addresses using your private key to authenticate the transaction. You create a transaction in your wallet with all of the required details. The transaction carries a bundle of information: the amount to send, receiving address, transaction fees, and more, then signs the transaction using your private key. Once a transaction is created, it's sent from your device to the blockchain network. The transaction will arrive at one of the computers that are part of the blockchain network. These are called nodes. Once it has reached a node, it is ready to be processed. The node will send it to the full network of other nodes, and your transaction will be added to a group of other transactions that needs to be confirmed. This is called a pool. A node can pull a transaction from the pool and add it to a block. After processing the block, they will add the block to the blockchain. How does a node know your transaction is valid and not fraud? Your transaction is authenticated by a signature using your private key. Remember when you created your wallet and received your public and your private key? Those keys are created through a public-private key algorithm. The public key is used to store your funds on. This means that the blockchain carries information that your coins are registered on your public key. This can be done either on the full public key or on the hash of the public key, which means that your public key is changed through a mathematical hashing algorithm into another set of characters. For more information on hashing, see the link below. When you create a transaction, your private key, the key that only you know, will be used to create a signature that is attached to the transaction. The signature is mathematical proof that you own the private key that belongs to the public key. This way, the nodes know you are the rightful owner of the funds you want to spend and that the transaction is legitimate. After the node has verified the signature, it adds the transaction to the block. This method is safe because there is no way that any classical computer can find what private key belongs to what public key. Provided that you never share your private key with anyone, you can safely store your coins on your public key. This is a core value that blockchain uses. Sounds perfect. But hold on, what about a powerful quantum computer? That changes the game completely. It can exponentially decrease the time required to derive the private key from the public key, allowing attackers to use the found private key to forge transactions and steal your funds. Worse off, it will be a simple search of the chain to find public keys and steal the stored coins. Bitcoin started to store coins on the hash of the key, instead of a full public key at a certain height in the chain. This means that now only the hash of your public key is published. The hash of a public key cannot be used to find the private key, not even by a quantum computer. This sounds great, as it should make Bitcoin quantum resistant. However, this is incorrect. The fact that you store your coins only on the hash of your public key does not mean your public key will never be visible. When you make a transaction, you have to publish your public key so the nodes can verify the signature. The full key is openly included in your transaction. As soon as you send your transaction, an attacker could get your public key, for example, through a man-in-the-middle attack. This attack can even be used to prevent your transaction from reaching the nodes. This way, an attacker has lots of time to use your public key, find the private key, and forge a transaction of his own to steal your funds. Another place where your public key can be obtained is in the pool. Even when your transaction is already added to a block, the node needs 10 minutes to process your transaction. In this time, your transaction can be hijacked. For more information, see the link below to a paper where this type of hijack is thoroughly explained. The solution is to use a new type of signature scheme, a quantum-resistant signature scheme. This type of signature is mathematically different from current signature schemes in the sense that there is no classical or quantum algorithm that can break this cryptography. So even a quantum computer cannot derive the private key from the quantum-resistant public key. Can this simply be implemented in an existing blockchain and solve the problem? It is not that simple. There are several issues due to the decentralized nature of blockchain that will be explained in the next video. Even in the best possible result, it is impossible to protect the full 100% of the existing circulating supply. The safest solution is to build a new blockchain from scratch and implement a quantum-resistant signature scheme from the very beginning, Genesis block. QRL, the quantum-resistant ledger, has done just that, implemented a quantum-resistant cryptographic scheme from Genesis, making blockchain ready for the future.